Hello everyone, good morning. This is lecture number 8 of analytical geometry. So in this class we're going to continue straight lines, right? So the previous class we have started straight lines. So I hope everyone have watched that video. So first what we will do is we will just recall what is meant by straight lines, right? So we will recall the previous lectures and then we will come back to this video, right? So first what we will do is we will just go through the slide of previous classes, right? So I think audio and video everything is clear, right? Okay, just a minute. Yes. So in the previous class we have started planes, right? The previous class we have started planes, and then we have solved three problems in the previous class, right? So first, what we have introduced in the previous classes, we have first introduced the symmetrical form of equation of straight line, right? So in order to write the equation of straight line in symmetrical form, you need two things. One is the direction ratio of that line, and you need any one coordinate on that line. So in order to write the symmetrical form of equation of line, you need to do two things. First, you need to know direction ratio of the line. Second is you need to know any one point on that line, right? So A is the one point that you already know, which is alpha, beta, gamma, and ABC is the direction ratio of the line, and x comma y comma z is any arbitrary point on the line. Then the equation of line is given by x minus alpha by a, y minus beta by b, gamma, z minus gamma by c is equal to k. And if I solve for x by z, you can see x is ak plus alpha, y is bk plus beta, z is ck plus gamma. That means if I vary k, I will get all points on the line, right? That is any point. That is any point on the line will be in this form only. Will be in this form only. This is what we have seen in the previous class, right? So depending upon this, we have solved three problems. We have solved three problems. First problem is find k so that the two lines are perpendicular to each other. So two lines are perpendicular. They have given equation of line symmetrical form. Two equations of line symmetrical form. You need to find the value of k so that the two lines are perpendicular. So you know direction ratio of this line, direction ratio of this line. So you need to make sure that it is of the form x minus alpha by a, y minus beta by b, gamma, z minus gamma by c. If not, you need to lightly revamp, right? So you can see minus 3, 2k, 2 is the direction ratio of this line, and 3k, 1 minus 5 is the direction ratio of this line. So since they are perpendicular, the corresponding directional ratio will satisfy the conditions for perpendicularity. A1, A2 plus B1, B2 plus C1, C2 is 0. So we will get k to be equal to minus 10 by 7. This is what we have seen in the previous classes. Find where the line meets the plane. So we have a plane, we have a line. So we need to find the point of intersection. Find where the line, this is a line L they are given. We need to find where this line meets the plane. So first you need to convert this in symmetrical form. For symmetrical form, we should have y minus something. But here you have 2 minus y. So just take minus common. So we'll have y minus 2 divided by, bring that minus 2 here. So we'll have minus 3. So first convert that to symmetrical form, right? Here we have z plus 3. But you should have z minus of something, right? Z minus gamma by c. So you put plus 3 as minus of minus 3 divided by 4. So you can see any point on the line will be in this form only, right? So I'm just equating to k, 2k plus 1 minus 3k plus 2, 4k plus 3. So any point on the line will be of this form only. Depending upon the value of k, you can get all the points. Now, we need to find the point of intersection. That means this coordinate has to lie in this plane. That means this coordinate has to lie in P. Substitute this x, y, z in P, you will get the value of k. This is what we have seen in the previous class. And the third problem that we have seen is find the ratio in which the joint 2, 3, 1 and minus 2, 1, minus 3 is cut by the plane x minus 2y plus 3z plus 4 is equal to 0. Find also the coordinate of point of intersection, right? This is also we have seen in the previous class. We need to continue with fourth problem, right? So make sure that you have watched all the previous classes because direction ratio and the direction cosine concept is very important, right? Uh, this is lecture number 8. So if you haven't watched all the previous classes, that is lecture number 1 to lecture number 7, go through all that, right? Okay. So we'll start with the fourth problem. So we'll start with fourth problem, right? So there is no doubt, right, up to now. Up to now there is no, right? Okay, so problem 4, I wasn't done, so I'll just quickly go through this. So prove that the distance of the point of intersection of the line and the plane. See, we have a line. So we have a plane, and we have a line, right? Just for understanding, I'm drawing the diagrams. So whenever you see analytical geometry, make sure that you draw diagram first. Then you will have more clarity about the problem. So you have a plane, you have a line. So first, find the point of intersection. Let us call this point to be equal to Q, right? Now you need to find the distance between the point of intersection and the point 3 comma 4 comma 5. And the point 3 comma 4 comma 5, you need to show the distance is 3, right? You need to show the distance between the point of intersection between the plane and the line to the point 3 comma 4 comma 5 is 3, right? Prove that the distance of the point of intersection of the line and the plane from the point 3 comma 4 comma 5 is 3, right? So first we will find the point of intersection, which is very easy. So first, what is the given line? So given line is x minus 3 by 1, right, in symmetrical form. So y minus 4 by 2 is equal to z minus 5 by 2. Let us say it is equal to k. So that means any point, any coordinate will be of the form x, y, z. So x is k plus 3, x is k plus 3, y minus 4 is 2k. So y is 2k plus 4, z is 2k plus 5. So that means this is the any point on the line will be of this form depending upon the value of k. Now this is any point on this is any point coordinate form, but you need to find a coordinate that should meet at p. That means this will satisfy this point. This point should lie on the plane p. What is the plane p? The plane p is x plus y plus z minus 17 is equal to 0, right? Now this point has to lie in this plane. So a k plus 3 plus y is 2k plus 4 plus z is 2k plus 5 minus 17 is equal to 0. So 2k, 3k, this will be 5k. 3 plus 4 is 7, 7 plus 5 is 12, 12 minus 17 is minus 5, implies the value of k is 1. Therefore, the point of intersection, the point of intersection, let us call it as q. So q point is given by substitute k to be equal to 1. So you will have k plus 3, 2k plus 4, 2k plus 5. So substitute k to be equal to 1. We will have 4, 6 and 7. So 4 comma 6 comma 1 is the point q. 4 comma 6 comma 7. Now you need to show that the distance of the point of intersection from the point 3 comma 4 comma 5, right? Let us call a to be 3 comma 4 comma 5 and q is the point of intersection. So find the distance between this square root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square will be root of 1 plus 4 plus 4, so root 9, which is 3. This is what we need to show, right? Prove that the distance of the point of intersection of the line and the plane from the point 3 comma 4 comma 5 is 3. Very simple problem. So now we'll move on to fifth problem. Problem number 5. Find the point in which the line, find the point in which, find the point in which the line minus of x plus 1 is equal to 1 by 5 y minus 12 is equal to 1 by 2 z minus 7 cuts the surface, cuts the surface, cuts the surface 11x square minus 5y square plus z square is equal to 0. They are given a surface, right? So you can see it is of the form pair of planes, right? It is in the form pair of planes. So you know the equation of pair of planes, right? Ax square plus by square plus cz square plus 2f y z zx, you know all this. So you need to same only, right? You see, you need to find the point in which the line cuts the surface. That is, you need to find the intersection point. So first you write that in symmetrical form. So the line L is x minus of minus 1 divided by minus 1. You bring this minus to the denominator. We should have x minus alpha. So put minus of minus. So you will have y minus 12 by 5 z minus 7 by 2 is equal to k. So that means your x will be minus k minus 1. Your y will be 5k plus 12. Z is 2k plus 7. So any point on the line will be of this form depending upon the value of k. Now it has to cut the surface. Now it has to cut the surface. That means this will satisfy this equation. 11x square minus 5y square plus z square is 0. So 11 times x square is minus k minus 1 whole square. Y square is 5k plus 12 whole square. So we will have 2k plus 7 whole square. You can do this, right? So you just apply a plus b whole square formula and substitute this. So you will have after simplifying you will have r square plus 5r plus 6 equal to 0. So solve this quadratic equation. You will have 2 and 3 be the roots. So that means this will intersect at 2 points. Sorry, minus 2 minus 3. So you will have minus 2 minus 3 to be the roots. So this will intersect at 2 points, right? So very simple. You just expand that in a plus b whole square formula. You will get the answer. So problem number 6. Find the very important problem. Find the image of the point P, which is 3, 5, 7 in the plane the plane 2x plus y plus z is equal to 6. So we need to find the image of the point 3, 5, 7 in the plane 2x plus y plus z is equal to 6. So very simple problem. So see, you have a point P, so which is 3, 5, 7. So we have a plane. So we need to find the image of this point, right? Let us say you are putting a torch here. This will reflect here. So we need to find the image of the point in this plane. See, very simple. First, what you have to do is you just image of this point in this line is nothing but you just draw a perpendicular, right? You just draw a perpendicular, and this is the image, right? This is the image. Yes or no? The image of the point to the plane. This will be the image. This is nothing but the image is nothing but where the line cuts this plane. Yes or no? The image of the point P is nothing but where this perpendicular line cuts the plane. Right? I just write it down what I have said. The image of the image the image of the point 3, 5, 7 on the given plane is the point in which is the point in which is the point in which line 2, 3, 5, 7 perpendicular to the given plane and then plane meets here. Right, very simple. So this image is nothing but you just find the equation of this line and you find where this line intersects this plane. That will give you L, right? So what is the equation of this plane? Is 2x plus y plus z minus 6 is 0. See how to find the equation of this line. How you will find the equation of this line? How you will find the equation of this line? Very simple, right? Now you can clearly see what is the equation of the plane ax plus by plus cz plus d is equal to 0, and what are ABC? ABC is nothing but the direction ratio of the normal. Now we can clearly see this IP is normal to the plane. That means the direction ratio of this IP is nothing but 2 comma 1 comma 1. Yes or no? See, equation of the plane is ax plus by plus cz plus d is equal to 0, and ABC is the direction ratio of normal. What is normal? Normal is a line that is perpendicular to the plane. Now we can see this line direction ratio is nothing but the direction ratio of the normal of this plane, which is 2 comma 1 comma 1. So you can easily find the equation of this line, right? So to find the equation of line, you know one coordinate on the line and you need to know direction ratio. So you know both. So you know a point as well as you know direction ratio of the line. So what is the equation of this line? Equation of this line is given by now equation of L. Let us call this as L, right? Call this as L. The equation of L is x minus alpha by A, y minus beta by B, z minus gamma by C. Here alpha, beta, gamma is a point that you already know, which is 3, 5, 7, and ABC is a direction ratio. So therefore, the equation of this line is x minus 3 by 2, y minus 5 by 1, z minus 7 divided by 1. Let us say it is equal to k. This is the equation of this line. Now it is very simple, right? You just find the coordinate form, substitute in plane, that will give you I. That's it. So that means your x comma y comma z will be in the form x is 2k plus 3, y is k plus 5, z is k plus 7. Now this point should lie, it should lie on, so it should lie on the plane, right? So 2x plus y plus z is equal to 6. So 2x, so 2k plus 3, k plus 5. So we'll have 4k, 4k, kk. So we'll have 6k. 2 3s are 6, 6 plus 5 is 11, 11 plus 7 is 18, 18 minus 6 is 12. So bring that side, we will have minus 12. So we will have k to be equal to minus 2. So k is equal to minus 2 will give you, if you put k to be equal to minus 2, that will give you the point I. It will give you the point I. Therefore, I point is given by 2. I is the image 2k plus 3. Just look the diagram. K plus 5, k plus 7. So k is minus 2. So 2 into minus 2 plus 3, minus 2 plus 5, minus 2 plus 7. So minus 4 plus 3 is minus 1. 5 minus 2 is 3. 7 minus 2 is 5. So minus 1 comma 3 comma 5 is the image of the point 3 comma 5 comma 7 on the plane 2x plus y plus z minus x is equal to 0. Is it clear? Okay. So we will do one more similar problem like this. Just like exercise also, right? Find the image of the point 1 comma 3 comma 4 on the plane on the plane 2x minus y plus z plus 3 is equal to 0, right? Same procedure. So instead of 3 comma 5 comma 7, we have 1 comma 3 comma 4, and we have a plane. So the answer is minus 1 comma 4 comma 8 exactly. We will do this problem. Very interesting problem. So a variable plane makes the intercepts on the coordinate axis such that the sum of squares is constant and equal to k square. Show that the locus of the foot of perpendicular from origin to the plane is x power minus 2 plus y power minus 2 plus z power minus 2 into x square plus y square plus z square is equal to k square. So very simple. Let us say we have a plane. So this has intercept A, B, and C. It has intercepts A, B, and C. So this has intercepts A, B, and C. This is our x-axis, this is our y-axis, and this is our z-axis. And this point, you know, A, comma 0, comma 0, B, comma 0, comma B, comma 0, 0, comma 0, comma C. Right? So it has an intercept A, B, C. A variable plane makes intercepts on the coordinate axis such that the sum of squares is constant equal to k square. Show the locus of foot of the perpendicular from origin to the plane. See, this is the origin, and let us say this is the foot of the perpendicular, right? Let us call this point to be N. See, you have to visualize this in 2D. So you need to show that the locus of the foot of the perpendicular from origin to the plane is given by this. You need to show that the locus of the foot of the perpendicular from origin. Let us say this is x comma y comma z, right? So show that the locus of the foot of a perpendicular from origin to the plane. So you need to show that this locus is given by x power minus 2 plus y power minus 2 plus z power minus 2 into x square plus y square plus z square is equal to k square, right? So show that the locus of the foot of the perpendicular from origin. So this is the foot of the perpendicular from origin to the plane. So visualize this in 3D, right? So you have a plane and you have a O is this origin, base is the O. We have a plane, so you have like this, right? So this is our x comma y comma z. This tip is our x comma y comma z. Now you need to show this tip x comma y comma z will satisfy this equation, right? Okay. Now first what we will do is we will find the equation of the line ON. Very easy, right? How to find the equation of line ON? Very easy. How to find equation of straight line? If you know one coordinate and if you know direction ratio. One coordinate is origin. So we know one coordinate is origin. And what is the direction ratio of ON? It is same as the direction ratio of the normal of the given plane. Yes or no? See, first I'll write it down. So what is our, let the variable plane, let the variable plane be x by a plus y by b plus z by c is equal to 1, which makes intercepts a comma b comma c, right? Which makes intercepts a comma b comma c. Now it is given that the sum of squares is constant and equal to k square, that is the sum of squares of intercepts. So it is given that the sum of squares of intercept is equal to k square, right? Let this be the variable plane, and this makes an intercept a comma b comma c, and it is given that the sum of squares is constant equal to k square. Okay, now first uh, what is the direction ratio of the plane? What is direction ratio of plane? Direction ratio of plane is nothing but direction ratio of the normal to the given plane, right? So, which is 1 by A, 1 by B, 1 by C is the direction ratio, right? AX plus BY plus CZ plus D is equal to 0. ABC is the direction ratio of the normal, right? Okay. Now, what is equation of line ON? What is the equation of the line ON? So you know one coordinate which is origin, and the direction ratio is given by 1 by A, 1 by B, 1 by C, because this plane normal direction ratio is 1 by A, 1 by B, 1 by C, and ON is also normal to the plane, which is direction ratio is same as the plane. So what is the equation of this line? X minus alpha by A, Y minus beta by B, Z minus gamma by C, let us say it is equal to some K, right? So we have X is equal to K by A, we have X is equal to K by A, Y is equal to K by B, Y is equal to K by B, Z is equal to K by C, right? So we need to show this, right? Okay, so let us find the value of this, we will multiply and we will show that is equal to K square, right? Let us multiply this. Okay, now, so we know X, Y, Z, right? Okay, so this is the coordinate of X, Y and Z. Okay, so that means any point on the line will be of the form K by A, K by B, K by C, right? This is any point on the line, yes or no? Because equation of this line ON is this and is equal to K, so you will find X, Y, Z. Any point on the line will be of this form. Okay, so that means surely this point lie in the plane, right? Lie in the plane. So what is the plane? It is X by A plus Y by B plus Z by C is equal to 1. X is K by A, so we'll have K by A square. Y is K by B, so we'll have K by B square. Z is K by C, so we'll have K by C square is equal to 1. So if I take K outside, we will have A power minus 2 plus B power minus 2 plus C power minus 2 is equal to 1. right? So we have k times a power minus 2 plus b power minus 2 plus c power minus 2 is equal to 1. That means the value of k is 1 divided by a power minus 2 plus b power minus 2 plus c power minus 2. What we are doing is we are trying to find the value of k in terms of ABC. So therefore, your x is k by a, right? And we know k is this. So that means this will be 1 divided by a into a power minus 2, b power minus 2 plus c power minus 2. And similarly, see, I'm just trying to find x, y, z in terms of everything to be k. But here we have k. I'm trying to find the value of k in terms of ABC. So similarly, y is k by b. So 1 divided by b into a power minus 2 plus b power minus 2 plus c power minus 2. And z is k by c. So 1 by c into, I'm just substituting a value of k here. So you know x, y, z. Now very easy. And everything is in terms of ABC only. Now substitute this here and here and prove that is equal to k square. Right? Okay. So first what we'll do is we will find the value of x power minus 2 plus y power minus 2 plus z power minus 2. Right? So first we will find this value x power minus 2 plus y power minus 2 plus z power minus 2. So this is same as uh, okay. So first we will find x square plus y square plus z square. What about x square plus y square plus z square? See, we need to find these two things. We need to multiply. So what is x square plus y square plus z square? So we know x, y, z. So if I square it, we will have 1 by a square. What I can do is I can take this a power minus 2, b power minus 2, c power minus 2 common. So this will be 1 divided by a power minus 2, b power minus 2, c power minus 2 whole square. And if I, this will be 1 by a square plus 1 by b square 1 by c square, right? I'm just taking common outside, that's it. Now what you can do is you can take LCM, I think. Now so you can take LCM and you can easily prove this, right? So we have a power minus 2 plus b power minus 2 plus c power minus 2 divided by um, I think what we can do is, see, let us write this as 1 divided by a power minus 2, b power minus 2, c power minus 2 whole square. Let us write this as a power minus 2 plus b power minus 2 plus c power minus 2. So this term and this square will get cancelled. So we will have 1 divided by a power minus 2 plus b power minus 2 plus c power minus 2. Right? This is the value of x square plus y square plus z square. Now similarly, you just find the value of 1 by x square, 1 by y square, 1 by z square, right? You need to find this and this, right? So what about 1 by x square? So 1 by x square will be, this will get reciprocated, right? So 1 by x will be this, so square, so you will have a square into a power minus 2, b power minus 2, c power minus 2 whole square. See, 1 by x will be 1 by x will be a into a power minus 2, b power minus 2, c power minus 2. So that means 1 by x square will be a square, and similarly this will be b square a power minus 2, b power minus 2, c power minus 2 whole square. Z square will be again I can take a square plus b square plus c square outside. So here you will have a power minus 2 plus b power minus 2 plus c power minus 2 whole square, right? Now we need to multiply this, right? We need to multiply this. So let us multiply x power minus 2 plus y power minus 2 plus z power minus 2 into x square plus y square plus z square. So this value is a square plus b square plus c square, a power minus 2, b power minus 2, c power minus 2 whole square. And this value is a power minus 2, b power minus 2 into a power minus 2 plus b power minus 2 plus c power minus 2, right? So you will have 1 divided by a power minus 2 plus b power minus 2 plus c power minus 2. Now this term and this one will get cancelled, right? So we'll have one term here. So we have this is a square plus b square plus c square. So you will have 1 by a square plus 1 by b square plus 1 by c square, right? So you will have 1 by a square plus 1 by b square plus 1 by c square. I think we are not getting right. Um, just a minute. Is there any mistake I have made here? So x square plus y square plus z square is 1 divided by a power minus 2 plus b power minus 2 plus c power minus 2. 1 by x square plus 1 by y square plus 1 by z square is a square plus b square plus c square. A power minus 2 plus b power minus 2 plus c power minus 2 whole square, right? Okay. So we can substitute this to be, we need to multiply this and then if it is k square. See, we can substitute this to be k square. We can substitute this to be k square because we know a square plus b square plus c square is k square. And we will have here, we will have 1 by a square plus 1 by b square plus 1 by c square. And I can substitute that to be, if I take k outside, I can substitute that to be 1 by k. So we will have k square, where you will have 1 by k, but you will have equal to k. But need to show it is equal to k square. Okay, so we need to do something. See, what we can do is, instead of multiplying separately, uh, as of now it is clear, right? So what we can, let us put this to be, let us put this to be equal to k square, because we know the sum of squares of intercept is k square, right? Um, so we will have a square plus b square is k square. Now a power minus 2 plus b power minus 2. So this I can write this as a power minus 2 plus b power minus 2 plus c power minus 2 is 1 divided by x square plus y square plus z square, right? Let's try to bring the term here. So we will have 1 divided by x square plus y square plus z square whole square, right? Yes, sir. I think I got the answer. So this is a square divided by x square plus y square plus z square whole square. Okay. The question is whole square. Sorry, that is what I missed. I think I got the answer there itself. Sorry, the question is whole square. Sorry, right? Now cross multiply this, we'll get the locus. Right? You can do in any stage, right? Just multiply this and this, you'll also get, right? But the question is x square plus y square plus z square whole square, right? Sorry, this whole square. We'll move on to the next problem. Is it clear? Okay. Move on to the next concept. Equation of line passing through 2 point, right? Equation of line passing through 2 point. That is the next equation. So line through 2 points. Line through 2 points. This is very easy. I'm just going to do only one problem. What is the equation of line that passing through 2 point? Very easy. So we have, let x1 y1 z1 x2 y2 z2 be 2 points. Let x1 y1 z1 x2 y2 z2 be 2 points. So to find equation of line, you should know one coordinate and the direction ratio, right? Now, very easy. So you can take one. You can take, you know, two coordinate, but you can take any one. So the equation is given by. Let us take this as coordinate. So x minus x1, y minus y1, z minus z1. So instead of alpha, beta, gamma, taking this point. What is the direction ratio? It is nothing but x2 minus x1, y2 minus y1, z2 minus z1. Very simple. So equation of line through 2 points given by x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. So we'll do one problem based on this. Find the equation of line and the equation of line joining the points 4 comma minus 5 comma minus 2 and minus 1 comma 5 comma 3 and show that and show that it meets the surface it meets the surface 2x square plus 3y square minus 4z square equal to 1 in coincident point. Coincident point means equal roots, right? So we need to find the point of intersection. You will have 2 points, that is, you will have quadratic as the one that you solve, but you will get equal roots. Coincident. See, first, what is the equation of what is the equation of line? What is the equation of line passing through joining these 2 points 4 comma 5 4 minus 5 minus 2 minus 1 5 and 3. So what is the equation of line? The equation of line is given by x minus 4 y plus 5 z plus 2, right? X minus x1 y minus y1 z minus z1 divided by x2 minus x1, direction ratio. So minus 5 5 minus of minus 5 will be 10, 3 minus of minus 2 will be 5. This is the equation of line. So any point on the line will be of the form. See, you can also divide by 5 because this is a direction ratio only, right? So you can also write this as minus 1 2 1. It will not affect the question, right? Minus 1 2 1. So that means your x is minus 5k plus 4, or y is 10k minus 5, that is 5k minus 2. So this is the any point on the line will be of this form. Now we need to show that it meets the surface. So we have a surface, yes. So it meets the surface. So what is the surface? Yes. So it is 2x square plus 3y square minus 4z square is equal to 1. Now substitute this point here. You will get a quadratic equation. Solve that. You will have equal roots. So you will get the equation as r square minus 6r plus 9 is equal to 0. To solve this, you will get 3 comma 3. So which is coincident. Coincident point means both are same, right? So we'll move on to next concept. So next concept is very important. As of now, we have seen only the symmetrical form of equation of line, right? So this problem has consumed time, right? You just change the question into whole square, then it will be very easy. Since I missed square, we are having to arrive the answer very easily. You just square it, right? You'll get k square. Now, up to this, there is one set, right? So up to this is set one of straight line, where we have solved problems based on symmetrical form of equations of line. Now there is also another form of equation of line which is called general form. So we're going to discuss about general form of equation of line. We're going to discuss what is the equation of general form of line, and then we're going to see many concepts, right? So next topic is general form of equation of line. Very important in exam point of view, right? So we will start this topic in 2 minutes, right? Let us have a 2 minute break. We will start the general form of equation of line. So all previous are based on symmetrical form. So these all the 9 problems are based on symmetrical form only, right? So now we will introduce the general form of equation of straight line, right? So it is nothing but two planes, right? So general form of straight plane is nothing but they will give two planes, right? So it is given by so a1x plus b1y plus c1z plus d1 is equal to 0, and they will give two one more plane a2x plus b2y plus c2z plus d2 is equal to 0. That's it, right? So you know that the line, see, this is one plane, this is another plane. By solving for this xyz, see, you just see this a1, b1, c1 as coefficient. You just solve for xyz, right? You will get this. You will get this, right? This is a line. Yes or no? So this is the equation of line in general form. So equation of line in general form, they will give two planes simultaneously. That is the equation of C. You just see this as a three variable system. Three variable homogeneous or non-homogeneous depending upon the value of d1 and d2. If d1 and d2 both are 0, it will be a homogeneous system of equations. You have three variable, but you have two equations, right? So you will have infinitely many solution or no solution, but majority of cases you will have infinitely many solution one day. That means you will get you will get the all the points on the line by solving this, right? But we are not going to solve. I'm just giving you an idea, right? So equation of straight line in general form is given by a pair of, they will give you two planes, right? They will give you two planes. Now so don't get confused, right? Next important thing is we're going to see how we are going to convert general form to symmetrical form, right? So how to convert the general form to symmetrical form, because we are most comfortable with symmetrical form of equation of line. So how to find the symmetrical form of equation of line? You have to know one point, which is alpha, beta, gamma, and you have to know direction ratio. So if you know both, you can write the equation of straight line: x minus alpha by a, y minus beta by b, z minus gamma by c. Right? Now we're going to we're going to uh, directly I will do the problem, right? I'm not going to give you the procedure. Directly I'll take problem and then I'll explain, right? So we're going to convert how to convert how to convert how to convert general form general form to symmetrical form. So general form is they will give a pair of plane a1x plus b1y plus c1z plus d1 is equal to 0, and they will give you one more plane a2x plus b2y plus c2z plus d2 is equal to 0. You need to convert this to x minus alpha by a, y minus beta by c, z minus gamma by c. So we're going to um, find how to do this, right? We're going to find how to do this. Okay. Okay. So find that. So I will take the problem directly and then I will explain you, right? Very easy only. So problem number 10, right? Find the symmetric find the symmetric equation of the line. Find the symmetric equation of the line x minus y is equal to 0, px minus z plus 8 is equal to 0. So they are given you equation of two planes, right? Equation of two planes. That is nothing but general form of equation of line. So you need to convert this to symmetrical form, right? So they are given in general form. You need to convert to symmetrical form. Very easy, very easy. See, you just draw the diagram and everything will follow very easily. So you have two planes, right? So you have two planes. You have two planes, right? You have two planes. This is the line we're going to find in symmetrical form, right? This is the one we're going to find in symmetrical form. This is our P1 and this is our P2. Now, very easy, right? Very easy. In order to find the equation of this line, you should know any one point on the line and you should know the direction ratio of this line. Yes or no? In order to find the equation of this line in symmetrical form, you should know any one coordinate on the line and you know direction ratio. To know one coordinate, very easy. You can easily find one of the coordinate, right? You just put x is equal to 0 and solve for y z, or you put y is equal to 0, solve for x z, or you put z is equal to 0 and solve for xy. You can easily get one of the point. Any one point is enough, right? Any one point is enough, and direction ratio is enough to find the equation of a symmetrical form. So we will find this later, right? We will find any point later. First, we will find the direction ratio of this line. How to find the direction ratio of this line? Any idea? How to find the direction ratio of this line? Any idea? You just try to be interactive. How to find the direction ratio of this line? See, we have two planes, right? So we have two planes. So P1 is, just try to write this in AX plus BY, AX plus BY plus CZ plus D is equal to 0. What is the direction ratio of normal of this plane, right? Of this plane. What is the direction ratio of this normal? Which is 1 comma minus 1 comma 0. And we have P2, which is second plane. So we have 3x plus 0y minus z plus 8 is equal to 0. And this plane has direction ratio 3 comma 0 comma minus 1. Right? So how to find the direction ratio of L? You just try to imagine. Very simple. So we know both the direction ratios, right? So that means this is the normal to this plane and this has direction ratio. This has direction ratio 1 comma minus 1 comma 0. And this has direction ratio 3 comma 0 comma minus 1. See, very simple. This L lies in P1 and this is perpendicular to the plane itself. That means this will be perpendicular to this line also. So let us say this has direction ratio a comma b comma c, right? Let us say let a comma b comma c be the direction ratio of L. Let a comma b comma c be the direction ratio of the line L which we are going to find. Now we can see this is the normal to this plane, right? So that means this line is perpendicular to the plane itself. That means it will be perpendicular to every line also. We already done this concept, I think, right? The line is perpendicular to the plane. It will be perpendicular to any line in this plane also. So this L lies in P1, right? L lies in P1. L lies in P1, right? And let us call this as some N, right? And NP1 is perpendicular to the plane, right? NP1 is a normal that is perpendicular to the plane. That means it will be perpendicular to the line also, right? It will be perpendicular to the line also. Now, what is the direction ratio of that normal NP1? It is 1 comma minus 1 comma 0. And what is the direction ratio of this? It is A comma B comma C. So they are perpendicular. So A1 A2 plus B1 B2 plus C1 C2 is 0. Call this as equation number 1. And similarly, this L also lies in P2 also, right? L lies in P2 also. That means the normal of the plane is perpendicular to L, right? So that means the normal of the plane is A comma B comma C. Sorry, normal of the plane is direction ratio of normal is direction ratio of the normal is 3 comma 0 comma minus 1, and this has direction ratio A comma B comma C. So they are perpendicular. So we have 3A plus 0B minus C is equal to 0. So solve for 1, 2, you will get the value of direction ratio. Is it clear? Let us rephrase this. Let's rephrase this. Correct only, but we will write this like this. Now L lies in P1, right? Also normal of the plane P1 is perpendicular to L. So what is the direction ratio of the normal P1? Is it clear? See, we already done this kind of problem, right? Is it clear? So we need to find ABC. That ABC lies on P1 as well as P2. So P1 has normal 1 minus 1 0. So therefore they are perpendicular. So we will have A minus B plus 0 is equal to 0, and we have 3A plus B minus C is equal to 0. Right? So solve for 1 and 2. You will get the direction ratio of the line L. So you can either do by cross multiplication method, or you can easily see here A is equal to B here. A is equal to B from 1. And here we have 3A minus C is 0. So that means C is 3 times A. So C is 3 times B, right? So we will write everything in terms of B. So A comma B comma C is the direction ratio. So this A comma B comma B comma 3B. Right? That means the direction ratio is 1 comma 1 comma 3. It is proportional only, right? So 1 comma 1 comma 3 is the direction ratio of the line which we need to have. Is it clear up to now? Is it clear up to now? One comma 3 is the direction ratio of this line. Now to find any point on the line, now to find any point, on the line L, right? You just put x is equal to 0 and solve for y z, right? Put x is equal to 0, or you can put anything, right? You just need to know any one point. So put x is equal to 0. So if x is equal to 0, we will have y is equal to 0. And if this x is 0, you will have minus z plus 8 is equal to 0. This is one of the coordinate, right? That means y is 0, z is 8. So 0 comma 0 comma 8 is one of the coordinate. See, symmetrical form need not be unique, right? In exam point of view, if you want to find symmetrical form, it need not be unique, right? I'm just finding one of the coordinate. You can put y to be equal to 0 and solve for xz. You can also do like that also. Or you can put z is equal to 0 and solve for xy also. If z is 0, x will be minus 8 by 3, and y will be same as x, right? So 0 comma 0 comma 8 is one of the coordinate. So therefore equation of line in symmetrical form. So we know direction ratio, which is 1, 1 and 3, and we know a coordinate which is 0 comma 0 comma 8. Therefore, it is x minus 0 by 1, y minus 0 by 1, z minus 8 by 3. This is the equation of any symmetrical form. Is it clear? So, we will do one more problem also so that you will have more clarity. So, whenever you are given two plane, that is the equation of line in general form, right? So, very easy to find that convert to symmetrical form, direction ratio, right? After that, let us assume this is direction ratio a comma b comma c. They are perpendicular, they are perpendicular. So you will have two equations in terms of ABC. Solve for ABC using cross multiplication method. You can find direction ratio. So to find any point, put x is equal to 0 and solve for yz, or put y is equal to 0 and solve for xz, or put z is equal to 0 and solve for x and y. This is a procedure to convert symmetrical form, sorry, general form to symmetrical form, right? So we will do one more problem so that we will have more clarity. Problem number 11. Find the symmetrical form of the line. Find the symmetrical form of the line 3x plus 2y plus z is equal to 5 and x plus y minus 2z equal to 3. Let us try to do this, right? Same problem. So the given, see, five are watching, right? Is it, if it is clear means just say it is clear. If it is not clear means you say not clear. Then only I will have an idea whether you are following or not, right? Just try to be interactive. Then only I will have an interest to take long classes, right? If you are not inactive means I will be losing the interest. Okay, so we'll continue this problem. So they are given P1 and P2. The first plane is 3x plus 2y plus z minus 5 is equal to 0. And what is the direction ratio of the normal? It is 3 comma 2 comma 1. The previous classes I have just written direction ratio. Whenever we are doing problems in planes, I think we have just written direction ratio. Just write direction ratio of normal of this plane. Similarly, we have P2. So P2 is x plus y minus 2z minus 3 is 0. And direction ratio of this normal to this plane is 1 comma 1 comma minus 2. So we need to find, so we have P1 and we have P2. This as normal 3 comma 2 comma 1 is the direction ratio of this normal, and this has direction ratio 1 comma 1 comma minus 2. This is the line we need to find a symmetrical form. So this has direct, let us say this has direction ratio a comma b comma c, right? So let L be the required line, L be the required line which has direction ratio a comma b comma c. Now again, I'm not going to write the same procedure again. So this L is perpendicular to P1 as well as L is perpendicular to P2. So L is perpendicular to P1 as well as L is perpendicular to P2. So just apply the concepts. So you will have 3a plus 2b, 3a plus 2b plus c is 0, a plus b minus 2c is equal to 0. Now solve this, you can get the direction ratio. of the line L to solve by cross multiplication method. So A by B by C by, to start with the second term. So we'll have 2, 2, 1, 2, 1, 3, 2, right? 2, 1, 3, 2, 1 minus 2, 1 minus 2, 1, 1. So minus 4, minus 1, 1 plus 6, 3 minus 2 equal to K. So we have A is minus 5K, B is 7K, and C is K. So let us take, you can take, if I vary K, you will have infinitely many A comma B comma C, all will be direction ratio only, right? Because all are proportionals. So let us take one of the direction ratio to be minus 5 comma 7 comma 1, right? This is a direction ratio. Just putting K to be equal to 1. So we know direction ratio. Now we need to find any one point on the line. So for that you can put x is equal to 0 and solve for yz, or y is equal to 0 and solve for xz. You can do anything, right? Let us put z is equal to 0. You can do anything. So put z is equal to 0. So you will have two equations in x and y, right? If z is 0, what is p1? So p1 is 3x plus 2y will be 5. 3x plus 2y will be 5. And in p2, if you put z is equal to 0, you will have x plus y is equal to 3. Now solve this. Let us multiply 2 here, so that you will have 2y. Let us multiply minus minus. So multiply 2 here, this will get cancelled. This will be 2x, will be 6, right? So you will have 3x minus 2x is x. 5 minus 6. 5 minus 6 is minus 1. So x is minus 1. So if x is minus 1, we have 3x plus 2y is equal to y 5. So 2y is equal to 5 minus 3x, and this will be 5 plus 3. So you will have y to be equal to 4. So a point on L is minus 1 comma 4 comma 0. So minus 1 comma 4 comma 0 is a point, right? You can find any point. I'm just finding one point, so which is minus 1 comma 4 comma 0. So therefore equation of line in symmetrical form is given by, so you know a point which is minus 1 comma 4 comma 0. This is our alpha beta gamma, right? And you know direction ratio of the line. Direction ratio of the line is minus 5 7 1. Minus 5 7 1. So therefore it will be x minus x1 divided by alpha, y minus beta by b, z minus gamma divided by c. This is the equation of line in symmetrical form. It need not be unique. Depending upon the point that you are taking, it will vary. It will vary. So problem 12. So find the equation of line. Find the equation of line through the point minus 2 comma 3 comma 4 and parallel to the planes, and parallel to the planes 2x plus 3y. See, you try to do every problem in your own, right? All will be easy only. Then you refer solution. 3x plus 4y plus 5z. Find the equation of line passing through the point minus 2 comma 3 comma 4 and it is parallel to the plane. Very easy. How to do? Just think about it. You need to find the equation of line. That line has to pass through minus 2, 3, 4. That means you don't need to find any point on the line. We already know one point in the line. Only thing is we need to find direction ratio. Right? If I know direction, if I found the direction ratio, then I can easily find the equation of line. It's very simple. So we need to find the equation of line that has to pass through this point minus 2 comma 3 comma 4, and you can see this line should be parallel to both the planes. So we have two planes and it should be parallel to both the planes, right? So that means very easy, right? So if it is parallel to both the plane means this will be some normal, this will be some normal to this plane. That means let us say this has direction ratio a comma b comma c. That means they are perpendicular, right? So this normal and this are perpendicular and this are perpendicular. Very easy, right? So what is P1? So we have P1 is 2x plus 3y plus 4z minus 5 is 0. And what is the direction ratio of normal? Is 2 comma 3 comma 4. Right? This is 2 comma 3 comma 4. This is P1. This is 2 comma 3 comma 4 is the direction ratio of this normal. And we have P2 and this has direction ratio. This has direction ratio 3 comma 4 comma 5. What about the direction ratio of the normal to this plane? Is 3 comma 4 comma 5. Let a comma b comma c be the direction ratio, be direction ratio of the line L, right? This is the line we need to find. Now again you can clearly see they are perpendicular, right? So L is perpendicular to P1, L is perpendicular to P2. So you will have 2a plus 3b plus 4c is equal to 0. 3a plus 4b plus 5c is equal to 0. Now solve for ABC, you can get the direction ratio and you know a point, so you can easily find the equation of this line. You can do this, right? Now solve for ABC, so A divided by B divided by C divided by, so 3 4 3 4 2 3 4 5 3 4. When you start this question 3 4 2 3 4 5 3 4. 15 minus 16 is minus 1. 12 minus 10 is 2. 8 minus 9 is minus 9. So one of the direction ratio is minus 1 comma 2 comma minus 1. Therefore equation of line is, so it passes through minus 2 comma 3 comma 4. See, remember this is not the two line, this is not the equation of any general form. They have said it is parallel to two planes. Don't if they give like comma, then only it will be general form. But here we have and, right? If they are giving the equation of any general form means it will be like this, right? It will be like this. But here they are saying that it is planes, right? They are saying that it is parallel to both the planes. Careful about that. So equation line is passes through minus 2 comma 3 comma 4, and this has direction ratio minus 1 comma 2 comma minus 1. So it will be x plus 2 divided by minus 1, y minus 3 divided by, this is our alpha beta gamma, this is our ABC, z minus 4 divided by minus 1. This is the equation of line in symmetrical form. prove that the lines are parallel. So they are going to give you two lines. You need to show that they are parallel, right? So they are going to give equation in prove that the lines are parallel. So they given two line x plus they will always put comma to separate these. That way it will be equation in general form. Very simple. You just convert this to symmetrical form, or you just find the direction ratio of this line. Find direction ratio of that line. And what is the condition for parallel? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Very simple, right? I think you can do this very easily. So they have given two set of equations, right? So we have one, right? Similarly, we have one more. So we need to show these two lines are parallel, right? So we have P1, P2, we have P3, P4. So P1, P2, P3, P4. Now you just find the direction ratio of this line and find the direction ratio of this line, right? And I'm just going to write roughly, right? In exam one of you have to write some story. Now this is the what is the direction ratio of the normal 1, 1, minus 1, and what about the direction ratio of this normal 9, minus 5, 1, right? And similarly, um, let's call this as L1, let's call this as L2, and this has direction ratio 6 minus 8, 4. 6 minus 8, 4. This has direction ratio 1, 8 minus 6. Right? Let A1, B1, C1. Let A1, B1, C1 be the direction ratio of L1. The exam point of view, you just draw the diagram, they will be impressed, right? By looking at the diagram itself, they will come to know that you have the conceptual clarity. So they will be perpendicular, right? So you will have A1 plus B1 minus C1 is 0. I'm not writing the same story. This L1 lies in P1. That means it is this direction ratio is perpendicular to the normal. So we will have A1 A2 plus B1 B2 plus C1 C2 is 0. And similarly, this line L1 is also in the plane P2. So it is perpendicular to normal. So we will have 9A1 minus 5B1 plus C1 is equal to 0. Now solve for A1 B1 C1. You will get the direction ratio of this normal. So you will have A1 divided by so you will have 1 minus 1 1 1 1 minus 1 1 1 minus 5 1 9 minus 5. So it will be 1 minus 5 1 minus 5 minus 9 minus 1 minus 5 minus 9 minus 5 minus 9. So one of the direction ratio A1 B1 C1 is one of them is minus 4 minus 10 minus 14, right? This is the direction ratio of this. One of them, any number that is proportional will also be direction ratio, right? I'm not putting that is equal to k and all. I'm finding one of the direction ratio. So minus 4, minus 10, minus 14. Similarly, let A2, B2, C2 let A2, B2, C2 be the direction ratio of L2. See what is L1? L1 is this line and L2 this line, right? That's a diagram. Now similarly, A1 that will be proportional. So they are 6A2 minus 8B2 plus 4C2 is equal to 0. Similarly, A2 plus 8B2 minus 6C2 is equal to 0. Right? I'm just A1, A2 plus B1, B2 plus C1, C2 0. I'm just applying this condition. This is A2, B2, C2. So just multiply that. 1, 8 minus 6. Okay, now solve for A2, B2, C2. So minus 8, 4, 6 minus 8, 8 minus 6, 1, 8. So this will be minus 48 minus 32, right? Sorry, plus 48 minus 32, 4 plus 36, 4 plus 36, 8 is a 40, 48 plus 8, 48 plus 8. So we will have A2 divided by 48 minus 12 will be 16, B2 divided by 40, B2 divided by 56. Therefore, direction ratio of the line L2 is given by 16, 40, 56. Right? So we know direction ratio of L1, direction ratio of L2, right? This is direction ratio of L1 and this is direction ratio of L2. So just apply the condition of parallelism. So A1 by A2 has to be B1 equal to B1 by B2 has to be C1 by C2. This is the condition for parallel. Condition for parallel. So you just see what happens. So minus 4 by 16 minus 10 by 40 minus 14 by 56. You can see all are equal, right? All are equal to minus 1 by 4. Therefore, they are parallel. Is it clear? See, if you understand the concept, everything is very, very easy to follow. Just have to understand the concept. That's it. For 3D geometry, understanding the concept and drawing the diagram will give you almost 70 to 80%. It will be completed by that time itself. I'll give you one problem for exercise now. So problem 14 is exercise problem. Find the angle between the lines. So they are given two equation of in general form. 2a 3x plus 2y plus z is equal to 0. X plus y. See, they can also give like this also. Equal to 0. This equal to that is equal to x plus y minus 2z. So instead of separating by comma, they can also give like this also, right? And they have given one more line, 2x minus y minus z is equal to 0, and it is equal to 7x plus 10y. Don't get confused, right? So take this as two separate planes P1, P2 by putting by equating every term to be equal to 0. Right? So you do this problem, right? Exercise problem. So same as previous problem. So 2, 3, 2, 1 is the direction ratio of normal of the first plane. 1, 1 minus 2 is the direction ratio of normal. Let us assume this has direction ratio A1, B1, C1, that line. Make use of Wepner condition. You will have two set of equation in A1, B1, C1. Solve that. You can get the direction ratio of the line L1. And similarly, 2 minus 1 minus 1, 7, 10 minus 8. So you will have 2a2 minus b2 minus c2 is equal to 0. 7a2 plus 10b2 minus 8c2 is equal to 0. Solve for a2, b2, c2. You will get the direction ratio of second line. So you know both the direction ratios. Find the angle between them using the formula cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square b2 square c2 square. Right? Just take the exercise. So you just use this formula, right? So you will get answer to be equal to, you will get pi by 2. That will you will get 90 degree. Right? Okay. So we're going to do some problem that is combined on lines and planes. See, we're going to do some problems that are going to involve line as well as plane. Here also, every problem involves line as well as plane, but we will do this, right? So you can do this problem, right? Very easy problem. You just find solve for A1, B1, C1 and A2, B2, C2 using the previous problem and just find the angle between them. You will get pi by 2 as the answer. We'll move on to problem number 15. Prove that the line is parallel to the plane. Prove that prove that the line prove that the line everything is very easy. I'm just going to give you into only y minus 4 by 3 z minus 5 by 4. They are given in symmetrical form is parallel to the plane, parallel to the plane 4x plus 4y 4x plus 4y minus 5z is equal to 0. So we need to prove that this line is parallel to this plane, right? We need to show this line is parallel to the plane. This is same as saying, we have a line and we have a plane, right? We have a plane. Now we need to show they are parallel. This is same as saying, see what is the direction ratio of normal to the plane? This is the direction ratio of the normal, right? Let us say this has direction ratio A comma B comma C. This is same as saying the corresponding direction ratios are perpendicular, right? What is the direction ratio of this plane? 4x plus 4y minus phi z is equal to 0. So direction ratio is 4 minus 5, right? This is same as saying what is the direction ratio of the line? It is 2 comma 3 comma 4, right? Now what is direction ratio of L? It is 2 comma 3 comma 4. It is in symmetrical form, x minus alpha by a, y minus beta by b, z minus gamma by c. And what is the direction ratio of the plane normal? Direction ratio of normal to the plane is 4 comma 4 comma minus 5, right? You just write the story, right? This is same as saying that they are perpendicular and so on, right? uh, yeah, just write the if the given plane if the given plane see, this is very important line you have to write in the exam. The given plane, sorry, if the given if the given line, like if you have line and plane, you need to show it is parallel, you just make use of this. If the given line is parallel to the plane, right? If the given line is parallel to the plane, then the given line must be perpendicular to the normal to the normal of the given plane. Yes or no? Very simple, right? Just do the diagram, right? That means it will be perpendicular to normal. This is the normal of the plane, and this normal has direction ratio 4 4 minus 5. We will have a1 a2 plus b1 b2 plus c1 c2. Just find this value. So 4 2s are 8, 4 3s are 12, 3 minus 20, there is 0. Therefore, they are perpendicular. If they are perpendicular means they are parallel. The normals are perpendicular means the corresponding planes are parallel, right? Still, we're going to do three more problems in this class. So, problem 16. Find the direction cosine. Find the direction cosines. Find the direction cosines of the line. Find the direction cosine of the line whose equations are x plus y is equal to 3, x plus y plus z equal to 0, and show that it makes an angle of 30 degree with the plane. With the plane y minus z plus 2 is equal to. So again, very simple problem. You just need to find the direction cosine of a line whose equations are they have given the general form of equation of line. So you have a line, right? You need to find the direction cosine of this line. DC, right? Not DR. So first we will find DR. After we will find DC by normalizing it, right? You will find direction cosine of this line, right? Uh, so very easy, right? what is they are given two planes. So first you find direction ratio of L. So this is what is a normal, the direction ratio of normal, it is 110. And what is the direction ratio of this normal? 111. So let A comma B comma C be there. So let A comma B comma C be the direction ratio of L. L is that is need to find. And again very similarly, like A plus B plus 0 C is equal to 0. And we have A plus B plus C is equal to 0. They are proportional. So the corresponding direction ratios are perpendicular. So we will have A1 A2 plus B1 B2 plus C1 C2 is 0. Solve for ABC. You can get the direction ratio. Right? Solve for ABC. So here we will have A is minus B. And here we have A is minus B. So C is 0. Right? So direction ratio is A comma B comma C. A is minus B, B, C is 0. So one of the direction ratio is minus 1, 1, 0. What about direction cosine? Just have to divide by its normalizes, right? Root of 1 square, 0 square, 1 by root 2, 0. This is the direction cosine, which is 1 minus 1 by root 2, 1 by root 2, 0. This is the direction cosine of L. Now you need to tell that it makes an angle. We have one more plane P. We have one more plane P. You need to show that this makes an angle 30-degree with this plane. Right? Just find the angle between the line and the plane. Now, now angle between line and a plane. See, angle between line and plane nothing but angle between line and normal of this line, normal to the plane. Right? Angle between two, what is angle between two plane? Angle between two plane is nothing but angle between the normals, right? Similarly, what is the line? What is the direction ratio of the line? Direction ratio of the line is minus 110. And what is the direction ratio of the normal to the plane? It is, this is the plane, right? 0, 1, minus 1. 0, 1, minus 1. So we know the direction ratio of the line as well as the plane. So we need to find the angle between them. So the plane is y minus z plus 2 is equal to 0. Right? Now just apply cos theta formula. A1 A2 plus B1 B2 plus C1 C2 divided by root of a square plus b square c square a square plus b square. We have cos theta to be equal to 1 by 2. So theta is equal to cos inverse of 1 by 2. This is 60-degree. So this is 5 by 3. 1 by 2, 1 by 2. What is cos 1 by 2? By 2, 1 by root 2, root 3 by 2. It is 60-degree, right? Make 60-degree or 30-degree. Oh, 1. Okay, okay. I think we need to find angle between. Just a minute, just a minute. I think you're making mistake. We need to find. Okay, I haven't tell you how to find angle between line and a plane, right? Okay, okay, okay. Yeah, actually, angle between line and plane is given by sine theta. It is not cos theta. So you just make a note of it, right? Angle between line and a plane is given by sine theta. right? You just make a note of it. It is given by sine theta, not cos theta, right? Angle between line and a plane alone. It is very easy to visualize why it is sine theta. See, if cos theta is the angle between, um, actually I have said one wrong information. See, this line has direction ratio something, and this plane will have direction ratio of normal. Actually, that too will not give you the angle between line and plane, right? Actually, cos of pi by 2 minus theta will only give you the angle between that line, right? See, very easy. I'll just give you a note, very important note. Just use it to find angle between line and plane, right? If theta is the required angle, if theta is the required angle, right? Angle between line and a plane, right? This has direction ratio and this has direction ratio of normal is given by sine theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square b1 square c1 square. So you can easily do with this problem, right? Actually, cos of pi by 2 minus theta will be the angle between line and plane. Cos of pi by 2 minus theta is sine theta. So just remember, if you want to find angle between line and a plane, it will be sine theta, not cos theta. Only for angle between line and a plane, right? Okay. Okay. So 17. Find the angle between line and a plane. The angle between the line is given by the line is given by y plus z minus phi equal to 0 is equal to x plus y plus z, and the plane x minus y plus z is equal to 0, right? So very simple. You just whenever you need to find angle between line and a plane, make use of sine theta. So very simple. You just find direction. What is direction ratio of the line L? So it is nothing but you can get that by solving. Let us say A1 B. Let us say ABC is the direction ratio of this line. So you will have 0A plus B plus C is equal to 0, and we have A plus B plus C is equal to 0. Now solve this, you can get the value of direction ratio of the line, right? See, this is this line. So they have given P1, P2. This direction ratio is ABC. That is, by solving this, you can get the value of ABC. Now, what is the direction ratio? This solve for ABC. So from here, you have B is equal to minus C. So we have A minus C plus C is 0 because B is minus C, A is 0. So A is 0, B is minus C. So ABC will be A is 0. Let us say B, C is minus B. So 1, 1, 0, 1 minus 1 is our direction ratio, right? And what about direction ratio of normal to the plane? It is 1 minus 1, 1. So whenever you need an angle between line and a plane, make use of sine theta is equal to A1, A2, B1, B2, C1, C2. A1 A2 plus B1 B2 C1 C2 divided by root of A square B square C square A square B square C square, right? So you will have sin theta to be equal to minus 2 by root 6. So theta is equal to sin inverse of minus 2 by root 6. This is the angle between the line and the plane. So when just make an important note, angle between line and the plane is given by sin theta, not cos theta. It will be cos pi by 2 minus theta. You just see how you just make a diagram. You will easily come to know how why it is cos pi by 2 minus theta instead of cos theta. So cos pi by 2 minus theta is sin theta. That is why we are putting sin theta. So actually it is cos of pi by 2 minus theta. Usually you will have cos theta is the angle between them. Here you will have cos pi by 2 minus theta. Okay. Around 18. So we will do two more problems and then we will wind up this. Problem 18. See, I think we have done this problem earlier itself. Right? Find the equation of plane. Find the equation of plane passing through passing through 2 comma minus 1 comma 0, 3 comma minus 4 comma 5, and parallel to the line 2x is equal to 3y is equal to 4z. Again, very simple. So find the equation of plane. That plane has to pass through 2 points. Just recall all the concepts of planes, right? So we need to find the equation of plane. Remember, we need to find the equation of plane, not line. That has to pass through 2 comma minus 1 comma 0, 3 comma minus 4 comma 5, and it must be parallel to the line, right? What is the line? 2x is equal to 3y is equal to 4z. What is the equation of line passing through a point? So we know that equation of line passing passing equation of plane. Equation of plane passing through a point x1, y1, z1 is given by a into x minus x1, b into y minus y1 plus c into z minus z1 is 0. Where a comma b comma c is the direction ratio of the normal, right? That we already know. So here it passes through. It passes through. You can take any one point 2 comma minus 1 comma 0. Equation of this kind is given by plane. This is the required equation, but we don't know A, B, and C. It also passes through. It also passes through 3 comma minus 4 comma 5. It will satisfy this equation. So we will have A into 3 minus 2, B into minus 4 plus 1, C into 5 is equal to 0. So we will have A minus 3B plus 5C is equal to 0. Right? Now, what is the equation of line L? The line L is given by, so let us take LCM for 2, 3, 4. It will be 12. So divide everything by 12. So 2x by 12, 3y by 12, 4y by 12. So that means the given line is x by 6, y by 4, z by 3. So this has direction ratio. This has direction ratio 6 comma 4 comma 3, right? So this direction ratio is 6 comma 4 comma 3, and you can see it is perpendicular to normal, right? L is perpendicular to L is perpendicular to normal, to the plane, right? So you will have 6a plus 4b plus 3c is equal to 0. Now solve 2 and 3, find the value of ABC, substitute in 1, you can get the value of, you can get the required equation of plane, right? So or you can also do like, see, usually what we will do is we will solve these two equations using cross multiplication method. You will have ABC in terms of k, substitute that here, take k outside, you will get the equation of plane. Or you can also do like, eliminating A, B, C from 1, 2 and 3. You can also do like this also. Just have to eliminate this, take determinant x minus 2 y plus 1, x minus 2 y plus 1 z. Here we have 1 minus 3 5, 1 minus 3 5, and here we have 6 4 3. You just expand this determinant. Here also, this way also you can find the equation of plane. Usually we will do cross multiplication method and then we will work it out. You can also do like this also, right? So if we solve this, you will have 29x minus 27y minus 22z minus 85 is equal to, this is the equation of plane that passes through 2 points, and also it is perpendicular to the line L. So the last problem I want to do, see, this kind of problem will repeat. They will give two lines, they will give 2 points and parallel to some straight line, right? This is the procedure. I'm not doing more problem in one topic, one kind of problem, right? Okay, problem number 19, the last problem that we're going to do. And the equation of plane, find the equation of plane and the equation of plane passing to the point minus 1 comma 3 comma 1 and perpendicular to the line, and perpendicular to the line 2x plus 3y plus 4z equal to 5, 3x plus 4y plus 5z equal to 6. So again, you need to find equation of plane that has to pass through this point minus 1 comma 3 comma 1. So it has to pass through minus 1 comma 3 comma 1. And what is the direction ratio? Let us say it is a comma b comma c. Find the equation of plane passing through, or let us say it is capital A comma B comma C, because we will be using capital ABC in the equation. So equation of plane passing through, so equation of plane passing through minus 1 comma 3 comma 1 is given by a into x minus x1, b into y minus y1, c into z minus z1 is equal to 0. See, all these are very important problem, right? So just because I'm doing only one problem, this will repeat by just changing the coordinates, right? Instead of this coordinate, they can use some coordinate. Instead of this line, they can use some line also. So this is the required equation we need to find, but we don't know the value of ABC, right? Now, very important, right? I'm just going to give you one very important trick here. Find the equation of plane that has to pass through this point, and it has to be perpendicular to the line. So this plane has to be perpendicular to the line, right? It should be perpendicular to the line. So perpendicular to the line. It should be perpendicular to this line. This is the line we have given, right? This line is perpendicular to the plane, right? This line is perpendicular to the plane. That is the same as it should be normal to the plane, right? It should be normal to the plane. Yes or no? And this another diagram, some more easier. So you can see this line would be perpendicular to the plane. That is same as that line will be normal, right? That line will be normal. Now you can see they have given general form, right? Now what is the direction ratio? What is the direction ratio of this P1 and direction ratio of this P2? This is the plane 1, this is the plane 2, right? P1, P2. Now what is direction ratio of this? It is 2, 3, 4. And what's the direction ratio of this normal? It is 3, 4, 5. What can you say about these three? All three are parallel, right? Yes or no? They are parallel. That means the corresponding direction ratios are proportional. That's it. See, you need to find the direction ratio. You need to find ABC, which is direction ratio, right? So the corresponding direction ratios are proportional. Um, so first, what we will do is we will find instead of this. Okay, so instead of this, okay, let us lightly rearrange this diagram, right? Lightly rearrange this diagram. I think you're getting my point, right? So it's if I draw it like this, it will be more clear for you. This is the line L, right? Now this line L should be perpendicular to the plane, right? Okay. Now this as let us find the direction ratio of L, right? Let us find direction ratio of L, which you can easily find. How? Let us say this direction ratio is A comma B comma C, right? Let small a comma B comma C be there. Let small a comma B comma C be the direction ratio of L. And let's make use of the previous concepts, right? So this has the first plane as direction ratio 2, 3, 4, and this plane has direction ratio of normal 3, 4, and 5. So to find the direction ratio of L, you need to solve these two. So you will have 2a plus 3b plus 4c is 0, and we have 3a plus 4b plus 5c is 0. So solve for ABC. Solve for ABC, you will get the answer to be 1 minus 2, 1. No. Yes, you will get the answer to be you will get one of the direction ratio to be, see, you will be having in terms of k, right? So you will have k minus 2k k, right? You just do by, ah, just a minute, I'll just take 1 minute rest. This has direction ratio 1 minus 2 1 is the direction ratio of L. Now you can see these two are parallel, right? That means the corresponding direction ratios are proportional. So this has direction ratio ABC. Direction ratio of L is 1 minus 2 and 1. They are proportional. So we have the direction ratio of normal of the plane P is parallel to direction ratio of L, right? So what is direction ratio of normal to the P? It is A comma B comma C. And what is direction ratio of L? Is 1 minus 2 1. So they are proportional. So we have A by 1, B by minus 2 is equal to C by 1. Let us say it is equal to K. So that means A value is K, B value is minus 2K, and C value is K. So we have found the value of ABC. Now substitute this ABC here, right? Substitute this ABC here. You will get the equation of plane as, you will get the answer as x minus 2y plus z plus 6 is equal to these kinds of problems are very important. You need to find an equation of plane passing through a point and perpendicular to a line. That is in general form, right? So you just have to make use of this idea. So I think it will be clear, right? So just practice all these problems. Uh, I think you will do any problem with this. So we're going to continue straight lines. We're going to continue straight lines in the next class also. So I'll just upload the notes in Telegram. Right. So thank you. We'll see you in the next class. All the best.